Okay, so now a colleague of Juliet is questioning whether her data is correct or whether the sample could realistically be taken from a population. And she says that the mean income of doctors in a city is 80,000. And this is Juliet's sample. And she's like, hang on, the real mean is 80,000. And you've got all these numbers. Are you sure it's okay? Are you sure it's a good sample? So Juliet says, right, let's run a test to find out if it's a good sample or not. So the test is, the hypothesis test is testing means. It's comparing means. It's comparing the mean of the sample to the mean of the population. And she wants to see, is it realistic that you get these answers if you were taking it from a population with mean 80,000? So the way we test our two tests for means is the z-test and the t-test. The z-test we use when we know the variance of the population, and the t-test when we don't know the variance, and we don't know the variance. So the answer is t-test. Okay, it's only one mark. That will do. Okay, part 2. State the null and alternative hypothesis for this test, right? The null hypothesis is that the mean is 80,000. So Julia's saying, yeah, that's the null hypothesis, that everything's fine. The alternative hypothesis is that the mean is not equal to 80,000. Now, this is a two-tailed test, guys. Its mean is not, the mean of the population is not equal to 80,000, because the reason I know it's a two-tailed, so one-tailed would be either greater than 80,000 or less than 80,000. The reason I know it's two-tailed is because she decides to carry out a test to determine whether her sample could be realistically taken from a mean of 80,000. So it's either 80,000 or it's not 80,000. She's not suggesting that her sample is more than 80,000, or she's not suggesting that her sample is less than 80,000. She just wants to know, is it the same? So that's the null and alternative hypothesis. Then part 3, finally, he says perform the test using a 5% level of significance and state your conclusion in context, right? So I still have, guys, my data here. It is the income data we're looking at. So we're going to go menu, statistics, stat tests, and now we're going to run this t-test, just the normal t-test. The data input method is data, because I've put in the data here. And my mu0 is 80,000. That's this. That's the mean of the H0. The list is income. This is all fine. The alternative hypothesis is that it's not equal to this. That is good. And then I'll put it into B. It doesn't matter, guys, because I'm about to, this is the last time I need this data. Put it into B, press OK. It will overwrite the data. Fine. Okay. So what we get is p-value. That's what I care about. The p-value is 0.610322. So p-value is equal to 0.61. What did I say? 610322. 610322. That's my p-value. Now that p-value is very big. It's big. It's way bigger than 0.610322. Is much bigger than 0.05. Therefore, and he says state your conclusion in context. So you gotta mention that there's not enough evidence to reject H0. Now, when he says in context, guys, I gotta mention the doctors and the money. So there's not enough evidence to reject H0. So 80,000 is the mean. So the sample could have been taken from a population with mean 80,000. So that's what the test says. The test says, no, these results are reasonable, that if you took this sample from a population which had a mean of $80,000, it's not unreasonable that you would get these numbers. Okay, that's question 1 finished.